Bismillahirrahmanirrahim. In this video, I will solve a problem based on randomized complete block design. This is problem 4.26 from the book. So, an industrial engineer is conducting an experiment on eye focus time, that is our response variable. He is interested in the effect of distance on the object, that is our main treatment. 4 different distances are of interest. Now, he has 5 different subjects available for the experiment. These 5 different subjects are 5 different blocks. Because there may be differences along the individual, he decided to conduct the experiment in a randomized complete block design. Do the experimentation at alpha is equal to 0.05. The first vector is distance, and the second one is subject, and the third one is response variable, that is eye focus time. I will write here focus time. Now we will have to enter the data. In order to enter the data, first of all we will enter the column. So you can see for each distance we have 5 different subjects. So I suggest you people first of all enter column data 4. Why I have entered 5 times? Because for each of the distance I have 5 different subjects. Now enter 6 for 5 times. So 6, and write enter the 8, and after that 10. So in this way we have entered the data in the Minitab software. Now for each subject you will have to write one number of the subjects, and once you have entered first 5, copy them and paste them 3 more times. Once you have done with this, now the next step is entering the data 4 wise, because for the distance number 4 and 666. So it is quite easy to enter data as compared to the latent scale or critical latent scale design. 76616, 76661 and 6, and it is 53325, 53325, and the last one is 64423, 64423. So we have entered the data. After the data entry, the major step has been done. Now we are going to start the analysis. Go to stat, ANOVA, GLM, general linear model, fit general linear model, select your response variable, that is eye focus time, click on factors, select the distance and the subject, then click on graphs. Here the graph, select 4 in 1, click OK, then go to results. In the result, select the expanded table. Usually it is the simple tables has been selected. Nothing else to do. Click OK. Upon clicking the OK, now wait for the result. View only result. Click here output only. So you have 2 factor distance and the subject. Both of them are fixed. Distance has 4 different levels. Subject has 5. Come down to the residual analysis. In the residual analysis, it seems that the first and third plot depicting that the data is found to be normally distributed. After that, the plot of the residual versus fitted value, it is depicting that the negative residual. Negative residuals are those that are below this central dashed line, negative symbol. And the positive residuals are those above this line. So the number of positive residual above the central dashed line are equal to the number of negative residual below this. Further, the residual versus observation order, the 4th number plot is depicting that there is no specific cyclic patterns, or there is no specific 5 different points are continuously below this dashed line or above this dashed line. So it means that the data is found to be independent. There are no issues of the multicollinearity. Click OK. Now the assumption have been verified. We go towards the model summary. The model summary explains that R-square adjusted 71.35% variation in the eye time has been explained by the distance and the subject. Now we'll talk about the analysis of variance. ANOVA, we have kept our significance level alpha is equal to 5% or 0.05. So it seems that the p-value associated with both of the factors is less than significance level 0.05. So both of them are found to be statistically significant. Now, since our treatment is the distance and it is found to be significant, we will have to perform a post hoc test. Post hoc test will tell us that which of 4 different distances has a significant difference from the rest of others that have make the ANOVA significant. So click on Start ANOVA, one-way ANOVA. Here select the distance. Select your response variable eye focus time and factor as the distance. And now you will have to click on the comparison. We are going to perform the Tukey's test, and please must confirm the check-in of these tests. Click OK and now OK. The ANOVA, now one-way ANOVA has been performed, but since we know that there is a difference exists, we are now interested in the Tukey's Trise comparison. Before going towards the comparison, let's have a look at this plot. So it's showing that the distance number 1 has a high eye focus time. So due to this high mean value, ANOVA becomes statistically significant. So now if we come towards the numerical result, we will see comparison that has been compared with the 4 are found to be statistically significant. Likewise, you can see 8 when compared with the 4, the p-value 0.012, and the 10 when compared with 4, we get the p-value 0.018. So because of these two differences in these two pairs, the ANOVA becomes statistically significant. Since both of the factors are statistically significant, now we are going to perform the regression analysis. Click on Stat, Regression, Fit Regression Model. Here select the response variable eye focus time. The predictors are distance and the subject. Click OK, and we will now get the regression equation for the prediction. So here is our regression equation, and both of our parameter or predictors are found to be statistically significant. Now we will have to go check the optimal setting that will help us to select the levels that will optimize the eye focus time. Click on Stat, then ANOVA, main effect plot. In the main effect plot, select the eye focus time, then select both of the parameters, so subject and the distance. OK, and now you got the plot in the plots. So for example, here you will have to decide whether you want to maximize or minimize the eye focus time. So if you want to minimize the eye focus time, so we can see that the level 4 of the subject has the least. However, we are basically interested in the treatment, so distance. So distance 8 is minimizing the eye focus time. So we will use this distance 8 in our analysis and further research work. Thanks a lot for watching the video. If you have any question, you can contact me on the WhatsApp, on the email address. I will help you as much as possible. Bye.